Hi everyone, welcome back. Today let us learn conduction of electricity in ionic compounds. A solution of an ionic compound in water contains ions, which moves to the opposite electrodes when electricity is passed through the solution. See, as we all know, ionic compounds are mainly made between two type of ions, that is cation and anion. So if I take an example of sodium chloride, sodium donates electrons and it gets a positive charge, and that electrons which have been donated is taken up by chlorine and it gets a negative charge. So a combination of cation and anion together gives rise to an ionic compound. So here there's mainly electrostatic force of attraction between the two atoms. So now, if I place NaCl in water, okay, so we should always understand that ionic compounds dissociate, means they split into their respective ions only in presence of water. So if I try to have the same experimental setup, and if I just take a solid NaCl and if I have the rest of the apparatus same, then it's very sure that solid NaCl will not conduct electricity. Okay, so this one thing we have to remember in mind, that solid ionic compounds, they do not conduct electricity. It is always when ionic compounds are in molten form. Molten means if I take NaCl and if I melt it, okay, it is called as molten, or another name is called as fused NaCl. And another way of conduction of electricity is when NaCl or an ionic compound is dissolved in water. So such type of solutions are called as aqueous solution. Okay, so in aqueous solution, NaCl will conduct electricity. Similarly, when NaCl is melted, that is fused or molten form, also NaCl conducts electricity. So now the reason behind this is that in molten or in presence of water, they will split. The two atoms will split into Na plus and Cl minus. Okay, so now what happens? See, now observe this diagram carefully. We all know that anode is positively charged electrode. Okay, positively charged electrode, and cathode is negatively charged charged electrode. Sorry. So now it's obvious that when there is positive charge electrode or a positive terminal, the negatively charged ion. So now, which is a negatively charged ion? Chloride ion. So chloride ion will start moving towards positively charged electrode. Similarly, on the other hand, we have cathode. Cathode is negatively charged terminal. So now, to negatively charged terminal, which atoms will, or which ions will get attracted to it? Obviously, the positively charged ions, that is Na plus. Okay, so this is the nature of law, basic nature of attraction and repulsion, that which states that positive and negative always attract, or negative positive, whether we're talking about positive negative terminals or positive negative pole. Okay, so they always attract. Similarly, positive positive terminals repel, negative negative they repel. So there's maximum repulsion here, whereas there is maximum attraction here. So now in this experiment is the same, students. Okay, so Cl minus negatively charged gets attracted to positive terminal. Similarly, Na plus positively charged gets attracted to negative terminal. So this way, there is continuous movement of electrons. See here, observe. You can E minus, you can observe E minus. So that is electron. So in this way, what happens? This continuous movement of electron. And we know the basic understanding of conduction of electricity or heat is only because of free electrons and mobility of electrons. Only when there are free electrons and when they are able to move in a particular pattern, only then conduction of electricity or heat happens. So that's why metals are excellent conductors of heat and electricity. Okay, so in this case, the same thing is happening. So ionic compounds, so a conclusion would be ionic compounds always conduct electricity in molten form or in aqueous solution. Okay, now in solid, they do not conduct electricity. Now suppose if I place a bulb here, okay, if I place a bulb here and the circuit is the same, I just have placed a bulb in between battery and the electrode. So obviously now we can expect, because NaCl conducts electricity, the bulb will glow brightly. Okay. Now on the other hand, if I remove the bulb and if I place or sorry, if I replace NaCl, okay, with a something solid, okay, like a solid NaCl or solid KCl or any ionic compound, and if I place a bulb, it will 100% not glow, because solid ionic compounds, they do not dissociate. So if they don't dissociate, there won't be any electrons, and if there are no electrons, they will not move freely and they will not conduct electricity. Okay, so this is the main understanding of conduction of electricity in ionic compounds. So here I have written the second point: conduction takes place when ionic compounds is in molten form or in aqueous form. Okay, that's what I explained. And the third point is that solids do not conduct electricity. So this is one NCERT question commonly asked. Like a situation is given. Okay, so there is a beaker taken, and then there are two situations, A and B. So in A, maybe they've given solid NaCl, and in the second one they've given molten NaCl. And they'll ask, like, which of the following will conduct electricity, or in which of the two cases the bulb will glow and in which it will not glow. Okay, so that kind of a hot question can be asked. Okay, so I think it was helpful to you. Thank you.